Solving a system of inequalities. So this is different than equations. These are inequalities. I have a couple examples set up here. I know I wrote them as equations because I'm going to first solve them as equations, and then I'm going to show you how inequalities work. Okay, so I'm using green here for the first one. Y equals 2x minus 3. Negative 3 is the y-intercept. 1, 2, 3. The slope is 2, so up 2 over 1. Up 2 over 1, 1, and then we connect the dots. And if this were an equation, which it is at the moment, these would be all of the solutions. So this line here represents all the solutions. We graphed 1, 2, 3, 4 of them, but there are infinitely many solutions in between the dots as well as beyond. So those are the solutions to that equation. The pink one, the y-intercept is 2. Slope is negative 3, so 1, 2, 3 over 1. 1, 2, 3 over 1, and that's enough dots. I can connect them. This pink line represents all the solutions to this linear function, and there are infinitely many solutions. This dot right here is the shared solution, as we saw in another video. So the point 1, negative 1, I'll just write that over here. 1, negative 1 is a solution to both of those functions at the same time. So that's the solution to the system of equations. If these were inequalities, so let's make this one, I'll say greater, and I'll make this one less than or equal to. So going back to the green one now, these are the still solutions because of the equal sign is still there. Right? But we're also talking about anything that makes y greater than this function. So anything above, what I would call above, if this were like a ladder leaning against a wall, this would be above. Anything above inside of here is also a solution to that inequality. So any point within here will make the y greater than when we plug the x value in. So let me just give you an example. If you plug in something simple like, we'll choose a point negative 2, 0. If I were to plug in negative 2 here, I would get negative 2 times 2, which is negative 4. Negative 4 minus 3 is negative 7. And the y value is 0, so 0 is greater than or equal to negative 7, which is true. So any point here is going to satisfy this inequality. This inequality is saying less than. So again, if this were a ladder leaning against a wall, less than would be below. So anything in this area satisfies this inequality. So you'll notice in the picture that anything over here, any point you place over here will not satisfy either one of these inequalities. It will not work when you plug them in. Anything in this area here, which is strictly green, will work in this function. Anything in this area over here, which is pink, will satisfy this function, and anything in this area, which is both pink and green, will satisfy both. So that's the answer that we're looking for when we talk about solving a system of inequalities. Any point in here, for example, negative 2, 0, any point in this area is a solution to that system. And so this double colored region is what we're looking for, and we could darken it if we wanted so we could really see it. Pink and green. And so that's the solution to a system of inequalities. And so the trick is, I always say, to shade above if it's greater, depending which way it's leaning. This would be above. This would be above. Some teachers will tell you to plug in points. They're called test points. It takes a little longer that way. Notice I tested a point here, and you could see that it works for both, so I know that I'm in the right area, that this is double shaded. Okay, so that's solving a system of inequalities.